Good morning, dear students. How are you today? I hope you're fine. Today we are going to take scientific notation, lesson 5 on unit 2. Before we multiplied whole numbers by powers of 10, remember? Now you'll read and write numbers using scientific notation. Scientific notation, so you can express large numbers as in example 1. Okay, we have models. Joseph King constructed a 23-foot model of the Eiffel Tower using 110,000 toothpicks. How can you use powers of 10 to write 100 and 110,000? Okay, one way to write large numbers to use scientific notation, as shown below. Scientists write numbers in this form to make computations easier. Okay, I want you to write this down on your notebook as we used to do. Using scientific notation, a number is written in scientific notation if it has the form c times 10 to the nth power, where c is greater than or equal to 1 and less than 10, and n is a whole number. So standard form I have here 2,860,000. Okay, I can see the product form here 2.86 times what? Times million. Okay, scientific notation 2.86 times 10 to the, okay, want to enlarge this for your eyes. Yeah, 2.86 times 10 to the 6th power. Can you see this? Okay, can you see it now? Okay, so I have here what again? Standard form, product form, scientific notation. As you see, the product form, I have here how many zeros? 6 zeros. So I here, if I multiply this number by 6 zeros, so it will give me this standard form. And here I know that 1 million, this is 6 zeros, so here 10 is repeated 6 times, so this is the scientific notation. Okay, writing numbers in scientific notations. Okay, as you see here in this table, I like this table vocab. Powers of 10, I have 10 power, 10 to the first power, it's 10. 10 to the second power, 100. 10 to the third power, okay, 1000, and so on. It's easy, it's very easy now. So I have, as described above, Joseph King used 110,000 toothpicks to construct his Eiffel Tower model. I don't know why. To write 110,000 in scientific notation, use powers of 10. It's easier to use the powers of 10s now. So the standard form here I have 110,000. So 1.1 times what? Times 100,000. Can you see here? I have here 1, 2, 3, 4, and I took 5 zeros, as you see, 5 zeros, and I put instead here 1.1. 1.1. Open your eyes here. 1.1. So 1.1 times 100,000, 5 zeros, 5 decimal places. Okay, so 1.1 times, when I wanted to be in the form of scientific notation, 10 to the 5th power. Why 5 zeros? Okay, 5 zeros, 5 decimal places. So Joseph King used 1.1 times 10 to the power 5 to the 5th power toothpicks to make his model of the Eiffel, okay, tower. Okay, write the number in scientific notation. Okay, we can do it easily now. Okay, so you read 7 times 10 to the third power as 7 times 10 raised to the third power, or 7 times 10 cubed, or 7 times 10 cubed. Okay, can you see this note? It's important also. Okay, so dear students, let's move to example 3 here. Comparing numbers in scientific notation, I have here another way. Okay, Mars has 2 moons, Phobos and Deimos. Phobos has a mass of 1.06 times 10 to the 16th power kilograms. Deimos has a mass of 2.4 times 10 to the 15th power kilograms. Which moon has the greater mass? Okay. Solution: to compare numbers written in scientific notation. First, compare the exponents. Okay, we have to compare the exponents. So the exponents, the powers here, are equal. If the exponents are equal, then compare the decimal parts. Okay, I have here 1.06 times 10 to the 16th power, and have this is for Phobos, and for Deimos I have 2.4 times 10 to the 15th power. So 16 here, 16, I here is the first step, I compare the exponents. 16 is greater than 15, right? And I have 1.06 is less than, okay, is less than 2.4, is less than 2.4. So here so the answer, Phobos has a greater mass. Phobos has a greater mass than Deimos. Okay, again, I want to explain this again to make it more easy or easier. So I have here the exponent 16 and 15. 16 is greater, as you see. So Phobos here has the greatest mass, okay? Because here I have exponent 16 and here 15. Okay, so when I compare between two decimals and in the scientific notation, so I do what I here compare between the exponents first, and if they are equal, I then compare between the decimal parts. Okay, check your answer. You can check your answer by multiplying both. Okay, 1.06 times 10 to the 16th power, so it will be the here 10 is repeated 16 times, so you will add here 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Why 14? Because we have two decimal places. This is important. This is why I mentioned it. I have here two decimal places. Here I have 16, so I'm writing how many zeros? 14 zeros. And the two decimal places goes for the remainder 2 here of the exponent. Okay, I have here 15 for another example to make sure that you understood it. I have here 15 to the power 15th. Okay, and here 1 decimal places. How many zeros? 15 minus 1 decimal places, so 14 zeros. Okay, my dear students, copy and complete the statements using less than, greater than, or equal. Okay, I have here to the power 21 to the power 22. So what do you think? To the power 22, it will be greater, right? Okay, to the power 12 to the power 12, the same. So I'm going to compare what? I'm going to compare the decimals for 5.1 and 5.28. So it will be 5.28. Okay. Let's move to,